Section 3.3. Exercise 1. Storing code in submodules. The Endowment NP Monthly module contains age, duration, and probability variables. These variables could usefully be stored in submodules to enable them to be used easily for other products. The aim of this exercise is to create and use two new modules, one for ages and durations and the other for probabilities. Open the R3S Modeler Life Foundation Delegate Binder and go to Exercise 1. This exercise provides more information on the steps to be followed. Try completing the instructions provided in the exercise before viewing the solutions in the next video. Section 3.4. Exercise 1. Solutions. Probabilities, age, and duration variables are not specific to an endowment program and will be useful to any liability product. We will therefore break down our Endowment NP Monthly module into two smaller submodules, one for the ages and durations and one for probabilities, which may then be used for other products. First, add a new module and give it the name Ages, Dates, Durations, Monthly. Cut the variables age, duration if, and step length from Endowment NP Monthly. And paste them into the new module Ages, Dates, Durations, Monthly. Second, add a new module with the name Prob Death Sur Monthly. Cut the remaining variables from the module Endowment NP Monthly and paste them into the Step tab of the new module, which we have just created. Finally, drag both modules as submodules into the original module, Endowment NP Monthly. Finally, close all components and rerun your model to check that it still executes without any runtime errors. Section 4.0. Copying components from Overview Workspace. We will now move on to creating a series of benefit and other cash flow modules, as illustrated in the diagram on page 15 of the Foundation Course Delegate Binder. These modules need to be copied in from the Overview workspace, which is saved in the training folder. Open the Overview workspace. Copy the module Training Assortment A, which contains several sub-modules, and paste it into the Foundation Course workspace. Modules highlighted in red are incomplete and ready to amend. Note that in case the variables in the Overview workspace have different global properties, a warning about replacing variables might be given. In case that happens, you will need to confirm such replacements. Close the Overview workspace. From the Training Assortment A module, copy the variable step length and replace the variable in the Ages, Dates, Durations monthly module. Note that the new formula now considers the exact number of days in each month by using the system variable step date, instead of the previous definition equal to 1/12. Section 4.1 Building up Benefit and Expense Cash Flow Modules. To build up the cash flows, there are modules already set up in the code we have copied in the previous video. Some of the code is already complete, but some still needs to be completed. There are usually 3 types of variables in each module: the amount of money, the expected cash flow, applying the probability of the cash flow occurring, and the interest on the cash flow. Let's start modeling the benefit cash flows. From the Workspace Explorer, open the module Benefit Death NP Monthly Start Point. Rename it to Benefit Death NP Monthly. Up to this point, the module contains only the variable names, and we need to complete the formulas for each variable in a similar way to how standard code is built up. Variable benefit death is the nominal amount to be paid in case the insured dies. Set the variable benefit death equal to sum assured, which is already defined in the database view. Variable CF benefit death is the expected cash flow after applying the probability of death. Set the variable to the nominal amount times the probability of death. Variable int on benefit death is the interest on the death benefit cash flow. Set the variable to the expected death benefit cash flow times the interest rate over half of the projection step. Once the module Benefit Death NP Monthly is complete, drag the module in as a submodule of the product module Endowment NP Monthly. Drag in the remaining benefit modules as submodules. Benefit Mat NP, Benefit Sir NP Monthly. To model the expense cash flows, open the module Expense Policy Start Point from the Workspace Explorer. Rename it to Expense Policy. The cash flow and interest on the cash flow variables are already complete. Let's complete the variable Expense Renewal, which is a portfolio variable. Portfolio variables will be explained later in the course. This variable should be calculated using the value of the variable at the start of the projection step using the .start syntax in Modeler. And applying the inflation rate for the period. Note that, in case you want to refer to the value of the variable at the end of the step, then you would need to use the syntax .end. Drag in the module Expense Policy as a submodule of Endowment NP Monthly. Section 5, Introduction to Events. The concept of events is explained in Section 8 of the Delegate Binder. Projection steps determine the intervals at which results are reported. However, within each projection step, there may be cash flows whose exact timing is important. Examples of this would be regular premiums, annuity payments, and coupon payments. Such cash flows are modeled in Modeler as events. A program can contain multiple events, and for each event, the dates when that event occurs must be specified. Depending on the dates of the events and the length of the projection steps, this means that an event could occur once or several times, or not at all in a projection step. For this cash flow model, we need to calculate probabilities and their dependence at the premium event. We will calculate some event formulae at the event and between the events, using portfolio variables and non-portfolio variables respectively. The step variables in such cases will be used to calculate the value for the last part of the step. When portfolio variables are used in events, we can refer to the value at the current and previous events using the syntax .cur and .prev respectively. Also, note that for the first event in the projection step, the syntax .prev equals to .start, since we cannot refer to an event in a previous projection step. In this case, .prev will mean the value of the variable at the start of the step. Open the module Premium Level Monthly Start Point and rename it to Premium Level Monthly. Later, we will adapt our code to be more flexible and ensure premiums are calculated accurately regardless of the projection step length. For now, we will continue to use monthly steps, but we can use an event to set up the premium payment dates so that we can easily determine whether a premium is paid in the step. Go to the Events tab and select the event date's default formula for the event, Premium Event, within the Events grid. This event will occur from the record start date to 1 day before the record end date at different intervals, depending on the frequency of premiums for each record. Interval definitions will vary for each event, and we can have several events in one program. Events are essentially mini-steps. The advantage of events is that it allows the projection step length to be increased whilst maintaining the accuracy of calculations. Step lengths do not have to be shortened to capture event-specific calculations. This is unique to R3S Modeler. For now, we will not use any event variables and will instead rely on the system variable event count, which represents the number of event occurrences within a projection step. Complete the formula for CF premium and define it as equal to the number of event occurrences multiplied by the premium modal. Multiplied by the probability in force at the start of the period. The interest formula has already been completed for you. Use the modules Premium Level Monthly and Commission Monthly as submodules of Endowment NP Monthly. Also, adjust the output report to include the following cash flows: CF Benefit Death, CF Benefit MAT, CF Benefit SIR, CF Expense Renewal, CF Expense Total, CF Premium, CF Com Renewal. Finally, we can add a filter to the model. To analyze filtered sample results, we can use the Sample Output Filter property within the program or data source. Add the filter EA Policy 1 to filter the first policy in the data file. Duplicate EA Policy 1 and call it EA Policy 2 to filter the second policy in the data file. Now set the program property sample output filter to EA policy 1 ? Or EA policy 2 ? The question mark must be added after the filter definition to apply the filter. The advantage of using filter components rather than directly entering filter formula is that the component can be reused. Finally, run the company monthly model in filtered sample mode. Confirm there are no errors before proceeding to the next video. Section 6.0 Event Variables Code. So far, the code has been written in a very simple way to run monthly throughout, as if the premium was paid on the first day of the month. We will now adjust the code to make full use of events to be able to change the projection step while maintaining accuracy. For this, we need to calculate probabilities and therefore age at the premium event. We can assume that surrenders happen just before the premium payment date, so they happen at the event. First, protect the existing modules so as not to overwrite the existing monthly modules. Then, copy in the module Training Assortment B from the Overview workspace. This module contains key event formulae and modules which will be used later. Click Yes if asked if you want to override existing variable global properties. Once this is done, close the Overview workspace. Open the module Premium Level Start Point and rename it to Premium Level. Event calculations allow users to perform specific calculations between steps. Go to the Event tab and select the event Premium Event. We'll analyze the 4 variables shown in red, which have been copied from the Step tab of the monthly module. Age, duration if, IND, prob deth, and prob if. Look at the formula for age and think about how you would expect the formula to change to calculate the age at the premium event. Let's look at the formula for the variable premium event length, which is already complete. The formula is similar to the one we used earlier for the variable step length. The only difference is that we are using the syntax .prev and .cur rather than .start and .end. It is therefore calculating the duration between events rather than between steps. Now try completing the 4 event variables in red using the syntax specific for events before viewing the solutions in the next video. Section 6.1 Event Variables Code Solutions. The completed event variables in the module Premium level are now shown. Have a look at them, including the syntax used to model events, .prev and .cur. Pause the video to double-check your entries. Now we have the relevant probabilities, we can calculate the cash flow for the premium. Add the variable CF premium event and define it as the premium modal multiplied by the probability for the policy being in force at the current event. The variable int onPremium event is already complete. Now we need to sum up the premium cash flows and interest on cash flows calculated in the event from the step variables. For this, we define the step variables using the relevant event variable followed by the suffix .total. So far, we have calculated the probabilities of death and surrender at the events. However, we have not calculated the probabilities for the very last part of the step between the last event and the end of the step. We will therefore use adjusted step probabilities that just calculate the probability for the last part of the step, that is, between the previous event and the end of the step. Note that we have previously copied in pre-written modules which already contain these adjustments. We will look at these adjustments once we have built our new product module using events. For now, we will continue using the premium level monthly module, allowing us to complete the model using monthly cash flows only, without introducing event variables. Section 7.0 Total Cash Flows Module. Let's have a look at the diagram in Section 4 of the Delegate Binder. The last component of the product module is the Total Cash Flows module. These total cash flows will then feed into the PVFP process. Go into the module CF Total Start Point. Unlock the module component if still locked. And change the name to CF Total. Go to the Step tab and observe that all variables are complete except for income and outgo. Look at the variable CF Benefit Total. Function ifdef returns a value if a variable is defined in the program, or a different value if not. The use of this built-in function brings flexibility to the code in the module, as this can be used independently of the existence of specific variables in the referenced program. For example, this code can be used as well for those programs where the variable CF_benefit_CIC does not exist. Now try completing the variables income and outgo before viewing the solutions in the next video. Section 7.1 Total Cash Flows Module Solutions. All the variables in the module CF_total are now complete. Pause the video to double-check your entries. Drag the module CF_total as a submodule of the product module Endowment NP Monthly. The module is now complete. You should now see 9 modules in the submodules grid. Copy the step variables in the CF_total module and add them to the output report, Revenue Account Report. Now we will make a copy of the product module to be able to calculate monthly as well as non-monthly cash flows. This module will make full use of events as well. Take a copy of the product module Endowment NP Monthly and call it Endowment NP. In this new product module, replace the sub-modules with the modules without the suffix _monthly. These modules have been amended to allow for the event calculations. All these modules already exist in the Foundation workspace as they were copied in previously from the Overview workspace. You can simply remove the suffix from the module names in the sub-modules grid. This will replace the modules using monthly cash flows with those using event variables. Now, let's check out the main differences between the two product modules. For this, we can use the compare function. Go to the View tab in the ribbon and select the Compare tab. From the Workspace Explorer, right-click on the module, Endowment NP Monthly, and select Add to Left Compare. Right-click on the module Endowment NP and select Add to Right Compare. Let's look at the following differences. The new step variable, premium, event length, is the length of the mini-step from the last event to the end of the step. Note that it uses the same formula as on the event premium event. Step variables ind prob sur and prob sur have been removed as they are no longer needed on the step. We are assuming that no surrenders will happen in the step as they will occur just before the premium payment date in the event. The formula of the step variable prob if does not allow for surrender decrements as these have been accounted for in the premium event. The variable prob death is calculated based on the probability that the contract is in force at the previous event or the beginning of the step. Finally, the death benefit cash flow needs to consider the total probability of death for the events and the lapses between the previous event and the current projection step. Duplicate the projection process realistic projection monthly and give it the name realistic projection. Adjust it to use the Endowment NP module. We have now finished the code for projecting cash flows using events. Take a copy of the model Company Monthly and call it Company. Use the new projection process in the new model. The next step will be to calculate the overall profit for the business and then the present value of future profits. From this point in the course, we will only work on the company model. Section 8.0 Calculation of PVFP, Reserve Temporary Formula. The PVFP process is shown on page 17 of the delegate binder. For calculating the profit, we need the net cash flows, the total interest, and the increase in reserve. Net cash flows can be calculated by using the income and the outgo defined in the product module. The interest on cash flows is already included in the product module. However, we need the value of the reserve to calculate the increase in reserve and the interest on the reserve. We will calculate the reserves using discounted cash flows, which will be done in a sub-layer. We will add a standalone variable in the realistic layer to call the reserves, but for now, this will be set to a dummy formula. Open the projection process, realistic projection, and open the NP-End program. Add the variable reserve PP in the step variables grid. Make sure the variable is defined with portfolio property yes and aggregates property yes. Set up the formula as follows. Now we are ready to start exercise 2, presented in the next video. Section 8.1, Exercise 2, Build the PVFP module. Open the delegate binder and go to Exercise 2. The aim of this exercise is to create a module containing the relevant variables to calculate the profit at each step. Then we will calculate the present value of future profits in the Rollback tab using rollback variables. The profit is made up of the net cash flow, interest on those cash flows and the reserve, reduced by the increase in reserve. We will ignore the solvency margin and tax for simplicity. Try completing the instructions provided in the exercise before viewing the solutions in the next video. Section 8.2, Exercise 2, Solutions. The completed PVFP module is shown. You should have the following step variables in your process module with the corresponding global and local properties. Pause the video to double-check your entries. Once we have modeled the projected profit cash flows, we need to calculate the present value of those profits in the Rollback tab. R3S Modeler calculates the rollback variables for a record as part of a backwards projection, starting at the end of the projection. Calculations are performed in reverse, step by step, until the projection reaches the portfolio date. Modeler calculates the rollback variables for a record after calculating all the step variables in all the projection steps for which the record is in force. Rollback variables are useful for calculations that rely on the values of variables in future steps. For example, we can only calculate the present value of future cash flows at each step after calculating the cash flows for all future steps. The initial value of a portfolio rollback variable is set in the initial value property. When calculating the present value of future cash flows, we can set this property to 0 or leave it blank. Go to the Rollback tab and add the variable PVFP. With its portfolio property set to yes and its aggregates property set to yes. Set the formula as the sum of the value of the variable at the end of the step and the profit for the period, both discounted by the discount rate over the projection step. Once the formula has been completed, add the PVFP module to the NP-End program in the realistic projection process. Update the output report to include variables reserve PP and PVFP plus all the step variables in the PVFP module. Now run the company model using filtered sample mode. Check your results match with that shown on screen. Section 9.0, Exercise 3, Calculating reserves using discounted cash flows in a sublayer. Open the delegate binder and go to Exercise 3. In this exercise, we will use some of the existing cash flow modules from the realistic projection to calculate the reserve as the discounted value of future cash flows. A gross premium reserve is often calculated in this way, by discounting future cash flows. We will reuse the product module, Endowment NP, to project the cash flows for the reserve. The main steps will be: Step number 1, create a new process module to calculate gross premium reserves by projection. Step number 2, create a projection process with a program that uses your new process module and your endowment product module. Step number 3, create a new reserving assumption set to be used to calculate your reserves by discounted cash flows. Step number 4, create a new model to test the reserving projection on a standalone basis. Step number 5, create a new two-layer model to calculate the PVFP, which calculates reserves by projection. Try completing the instructions provided in the exercise before viewing the solutions in the next video. Section 9.1, Exercise 3, Stages 1 to 3. The first step would be to create a process module for the calculation of the reserve by discounting cash flows. As these calculations are similar to those for the calculation of the PVFP, we can take a copy of the PVFP module and save it as gross premium reserve. The main difference is that only the cash flow-related variables will be considered, and therefore the reserve-related ones will be ignored for the calculation of the present value. Go to the Step tab. Amend the variable profit to be the sum of net cash flows plus the interest on those cash flows, therefore not considering the increase in reserve. Keep the step variables net cash flow and profit in the module and delete the rest of the variables. Go to the Rollback tab. Rename the variable PVFP and call it DISC-CF. The variable DISC-CF needs to be defined as the value of the variable DISC-CF at the end of the step, minus the profit discounted by the discount rate over the projection step. Here we subtract the profit rather than adding it, as variable DISC-CF is meant to be a liability. For instance, variable DISC-CF will take a positive value in case the present value of all future profits is negative. Make sure the portfolio property is set to Yes. Now define the variable reserve, which is the reserve in force, as the maximum value between 0 and the value of DISC-CF at the start of the step. Finally, let's define reserve PP, which is the nominal reserve. This is the reserve in force at the start of the step, divided by the probability of the contract being in force at the start of the step. Make sure the properties portfolio and aggregates for these rollback variables are set to Yes. Once we have completed the gross premium reserve module, we need to create a new projection process using the new process module and the existing endowment product module. Add a new projection process and call it Reserve Projection. Reserves will be calculated by projecting and discounting cash flows, so set the start date to portfolio date and leave the end date blank, as we will be using the model end date property to set the end date. Add a new program to the canvas with the name NP-End. Add the product module Endowment NP and the process module Gross Premium Reserve to the program. Next, we will create a new assumption set to be used to calculate the reserve based on a different set of assumptions. Take a copy of the assumption set, Realistic Assumptions, and save it as Reserve Projection Assumptions. The assumptions will be conservative compared to the assumptions on the realistic layer. It will be prudent to calculate the reserves, assuming that policyholders do not surrender. For this, you need to amend the assumption table, which includes the surrender rates, so that all percentages are set to 0. Either keeping the same dimensions or just one row for the dimension represented by the duration in force. To amend the assumption table, you need to select the current formula. Right-click and select Specify Array Constant. And then click on Configure Dimensions. Try completing the instructions provided in the exercise before viewing the solutions in the next video. Section 9.2, Exercise 3, Stages 4 to 5. The completed assumption set, Reserve Projection Assumptions, is shown. You should now have the relevant assumption set variables in the assumption set with the corresponding values. Also, ensure that the values in the surrender rates table are correct. Pause the video to double-check your entries. Once all the reserving components have been added to the workspace, we will create a new model, Reserve Projection. This will just calculate the reserves and therefore confirm the reserving projection works as expected before we adapt the company model. Set the model properties, portfolio date and model end date to the same properties as the company model. Add the data process to the data layer and add the projection layer using the new reserving projection process and call it Reserving Layer. Set the projection step length as follows. The model will run monthly for 3 years, then yearly thereafter. Set the assumption set and aggregation report properties for the program. Now, run the model using live mode. Confirm the model runs without any errors. We will now move on to the last stage of the exercise. The reserve layer will calculate the per policy reserve, and this value will be called by the reserve PP variable in the realistic layer, replacing the temporary formula. First, we will amend the assumption set, reserve projection assumptions, to remove the variable expense renewal. As we will now use the value of the fixed expense calculated in the realistic projection. Now let's adjust the company model to include a reserving layer to calculate the reserves using discounted cash flows. Right-click in the realistic layer box to add the reserving sublayer. Your new two-layer company model will now look like this. Adjust the layer properties so the reserving layer uses the assumption set, reserve projection assumptions, and the aggregation report, revenue account report. Set the projection step lengths to 1 month. Now it's time to amend the temporary reserve formula in the realistic projection to call the value of the nominal reserve calculated in the sub-layer. Replace the temporary formula in the conditional statement with the call reserving layer.reserve PP. Run the model using filtered sample mode. Check your model results with that shown on screen. Section 10.0, Exercise 4, Error Trapping. Several errors have been created intentionally in the Workspace Error Trapping exercise, located in the Start Point folder. The aim of this exercise is for you to practice how to debug errors in R3S Modeler. Open Error Trapping exercise. Run the company model in live mode. "13 generator errors will show up in the run summary. Select the message, right-click and select Expand All. If you double-click on the error, you will be taken to the component where that error occurs. Also, you can select the error and press F1 on your keyboard to get additional information from the help files on why the error occurs and how to solve it. Once you make the necessary changes to solve the error, rerun the model and see if the original error message has disappeared. It is best to address these errors one at a time. The first generator error message in the runtime summary says, "Benefit death, sum assured, is not recognized." If we double-click on the message, it takes us to the step variable, benefit death, in the module benefit death NP. This error occurs when you refer to a variable that does not exist. Perhaps the name of the variable was not typed correctly. To solve this, right-click on the formula and click on Select Variable to choose the correct variable name, sum_assured. Close all the components and run the company model again on live mode. There are now 12 generator errors, as we have fixed the error related to the sum assured. Now try solving the rest of the errors before viewing the complete solutions in the next video. Section 10.1. Exercise 4. Solutions. The first generator error message says, "Ind prob death." The non-portfolio variable, mortality rates, does not have an accessible definition in the program or its assumption set. This means that the stated non-portfolio variable is referenced by another variable in a program but cannot be found. If it is correct for the variable to be a non-portfolio variable, Modeler expects it to be defined in the program, an assumption set associated with the program, or an assumption set associated with the layer. We'll use the find_replace function to look for occurrences for the variable mortality rates in the company model. Observe there are two occurrences, one for the variable name and one for the reserving assumption set. But the variable mortality rates does not seem to be defined in the assumption set in the realistic layer. Open the realistic layer in the company model and see that the assumption set originally attached to the program is now missing. Reattach the assumption set, realistic assumptions. close all components and rerun the model. The runtime summary shows there are 9 generator errors. The changes we have just made have corrected several of the previously existing errors, and possibly new errors may have now shown up for the first time. The following generator error says, CF expense renewal, the extension START used with expense renewal is not valid in this context. If we double-click on the error, Modeler takes us to the variable CF expense renewal, where the syntax expense renewal.start is used. When the error says that the extension is invalid, to solve the error we would need to either change the extension in the formula or change the portfolio property of the variable the formula references. In this case, the variable expense renewal was originally defined as a portfolio variable, whereas its portfolio property is now set to no. Correct the portfolio property of the variable expense renewal. Set it back to yes. Close all components and rerun the model. The next generator error message says, Reserve PP, reserving layer is not recognized. If we double-click on the error, it takes us to the variable reserve PP, and here it seems that the location specification is not correct, as it references the sublayer reserving layer, whereas the correct name is reserving_layer. Amend the formula to reference the correct location and rerun. You can also copy the name of the sublayer and paste it in the formula to avoid mistyping the name. Close all components and rerun the model. The following error message says, int on benefit death. The non-portfolio variable, int rate, does not have an accessible definition in the program or its assumption set. This error is similar to the one with the variable mortality rates. Use the find replace function to look for occurrences of the variable int rate in the company model. We would expect int rate to be found in the realistic assumptions, but this is missing. Open the realistic layer and check the assumption set, realistic assumptions. Go to the Variables tab, and we can see int rate is missing. Add it again and set the formula to 3%. Close all components and rerun. There is now only one generator error remaining. This says, outgo, no IIP value can be set for this variable. Its formula could not be used, and none of the program's inputs supplied a value. The sequence of references that cannot be calculated is CF expense total, CF expense renewal, and step length. If we double-click on the generator error message, we are taken to the step variable outgo in the module CF total. If you check the help file by clicking F1 on the message, it says that the cause of the problem would be that an initial value for the portfolio variable, outgo, cannot be found and cannot be calculated using the formula in the program either. However, variable outgo is a cash flow variable, whose value refers to a period, unlike portfolio variables whose value usually refers to a specific point in time. Therefore, the variable outgo should have a portfolio status as no instead. Amend the portfolio property and rerun the model. Note that all errors have now been resolved and the model executes successfully. Section 11.0, Exercise 5. Modeling a term assurance using existing modules. Open the delegate binder and go to Exercise 5. So far, we have calculated the PVFP for endowment assurance policies by reading in the endowment data file, setting some assumptions, and writing code to model the cash flows, reserve, and PVFP. We may reuse our existing modules to model other products. The aim of this exercise is to calculate the same for a term assurance product by reading in a new data file and adjusting the code accordingly. Main steps to follow are: Step number 1. Add a term assurance data source in the data process. Step number 2. Reuse existing modules and amend as necessary to model a term assurance contract and add a term assurance program to the existing projection processes. Step number 3. Adapt as required and rerun the company model. Try completing the instructions provided in the exercise before viewing the solutions in the next video. Section 11.1, Exercise 5, Solutions, Part 1. The term assurance data is in a different layout compared to the endowment data, so we will use a different data view for this. Copy and paste the data view, TA Data CSV view, from the Overview workspace. Now close the Overview workspace. We'll now add a new data source to your existing data process to read the term assurance data. For this, you can duplicate the data source EA data and amend the properties, data view and data file accordingly. Add a new filter to filter for the first term, assurance policy, in the data file and call it TA_policy_1. Apply the following formula. Duplicate the endowment NP module and call it term_assurance. Let's think about the differences between an endowment assurance and a term assurance product. Term products do not pay maturity nor surrender benefits. Therefore, remove the sub-modules Benefit MAT NP and Benefit SIR NP from the term assurance module. Add a new program called Term to the realistic projection process. Add the product module Term Assurance and the process module PVFP to the program. Also add the standalone variable Reserve PP. You can copy it from the NP End program. Similarly, add a term program to the reserving projection process with the modules Term Assurance and Gross Premium Reserve. Set the assumption set and aggregation report properties of the term program in both layers. Also use the new filter in the program property Sample Output Filter. We could apply the same sample output filter on the data layer and reserving layer. This would allow us to see values in those layers in a filtered sample run. At this point, it will be easier to check your term assurance program by temporarily suppressing the endowment data source and program in the model. We'll see later how to control the data flow when you have multiple data sources and programs. Set the suppressed property for the endowment data source in the data process to yes. Do the same in the endowment programs of the realistic and reserving projection. Run the company model using filter sample mode. Once your model has finished running, check your model results with that shown on screen. Section 11.2, Exercise 5, Solutions Part 2. To run both programs, NP-end and term together, first unsuppress the endowment data source in the data process within the model. Do the same with the endowment programs in the realistic and reserving layers. Run the company model. Runtime errors occur because both the endowment and term datasets are being passed into both NP-end and term programs. Each program is designed to process only its own data, so mixing the data causes the runtime errors. Now we have a couple of programs and data sources. If we unsuppress the endowment data, this is what will happen. "125 records will pass through both sets of programs, which is incorrect. As we previously suppressed the endowment data source and the NP-end programs, this forced the term data to pass through only the term programs. We will now set up the model so that each data source passes its data records to the corresponding programs. The best way to do this is to use a data flow category. By default, all data goes through all programs in the layers, so we need to make sure that each data record is processed only by the relevant programs. Categories can be used to control the flow of data through the calculations performed by a model. This ensures that programs only process data from data sources with a matching category as defined in the category property. Also, programs will only pass values between layers to programs with the same category specified in the category property. Add 2 new categories with the category type Data Flow. The first one is called EA Data Flow. The second one is called TA Data Flow. In the data process, select the relevant data flow categories for each data source. Similarly, select the appropriate category for each program within each layer to ensure that the correct data flows through the corresponding program. Now run the company model using filtered sample mode. Open the aggregated results from the run summary. Observe in the Audit tab that each program receives the correct data records. Section 12.0 Parent and Child Programs. The programs in the same projection process, without any links between them, will process data records independently of one another. However, we can establish links between the programs within the same projection process that will enable them to interact, passing values between each other in the same projection step. When we establish a link between two programs, we create a hierarchical relationship between them, and we call one program the parent program, and the other the child program. A child program can only have one parent program, but a parent program can have multiple child programs. For example, the parent program may calculate the total asset value and the total reserve and capital. Based on this and the asset mix, the parent program could decide which bonus rates to feed back into the liability programs and which assets to buy or sell in the asset programs. Add a program to the realistic projection process and give it the name non-profit fund. Link the NP end and term programs to non-profit fund, making it the parent program. To do this, click the link symbol in the top right-hand corner of each child program and drag it to the parent program. Now add the following variables to the Step tab of the Non-Profit Fund program. You can drag them in from the Variables chooser. First, the cash flow variables used during the course: CF benefit death, CF benefit MAT, CF benefit SIR, CF benefit total, CF com total, CF expense total, and CF premium. And the rest of the variables: income, increase in reserve, net cash flow, outgo, prob if, profit, and reserve. In the Rollback tab, add the variable PVFP. To sum the cash flow on death across both child programs, we could write the formula for CF benefit death in the parent program as np-end.cf benefit death plus term.cf benefit death. However, since we want to total CF benefit death from all of our child programs, we could use the child dot syntax and write child.cf benefit death. In addition, since we want to aggregate the values of variables that share the same name as the parent program variable across all child programs, we can use the this var syntax. Similarly, we can use the syntax parent.thisVar in the child program to call values of variables from the parent program into the child programs. Use the same formula for all step non-portfolio variables. For step portfolio variables, use the suffix .end. Use .start for the rollback variable PVFP, as the rollback tab operates in reverse. Attach the output report, revenue account report, to the parent program as an aggregation report. Finally, run the model in filtered sample mode. Once the model has finished running, open the aggregated results from the run summary. And observe that only one record is processed by the parent program. If using a calculation grouping, records from the child program could be further disaggregated based on the grouping criteria used in the grouping component. Otherwise, values from the child programs are aggregated in just one record in the parent program. Check your model results with that shown on screen. You've now successfully completed the model build for the Life Foundation course. Congratulations! The sections that follow are optional appendices, which you may explore at your own pace if you'd like to deepen your understanding.